Remember 1430.
Okay.
All right. Yesterday we did perimeter. Somebody tell me what is perimeter. I didn't say tell me how to find it. I said what is it, Carl?
The distance around a straight-sided figure.
Okay, I said like the baseboard. This blue thing around the bottom of my wall. You measure down one side, measure all the sides, and add them all up. The distance around the bottom. That is finding the measure for perimeter. Today we're doing area. It's different than perimeter. Don't think they're the same. They are totally different. When we measure perimeter, we're measuring how far around the figure. When we measure area, here we go. When we measure area, we measure how many, keyword right here, squares cover the figure. Perimeter tells us how far around the figure. Area tells us how many squares cover it. Look down at the floor right by your desk. If we counted all these square tile in this room, we would have the area of this room. The floor is completely covered with squares. Okay? Even if it's partial squares like up here in the front, it is covered with squares. That is area. Okay? How many squares cover the figure is area. Alright. Today we're going to talk about rectangles and parallelograms. So let's first define what a rectangle is. Can someone tell me what it looks like first?
Two squares?
Two squares.
Like put together?
Okay, but help me out a little better than that. Trenton?
Four sides.
Four sides. Okay, so I'm going to draw something that has four sides, which means it's quadrilateral. Good job.
And two of the sides are the same length, and the other two are a little smaller than the other two.
Okay, but will be the same length. Opposite sides are congruent, or the same length, okay? I got to have more than that, y'all. More info than that. I can't draw it.
One side,
Go ahead, Brad.
both sides are parallel.
Okay, no. Opposite sides are parallel. So far we've got a four-side figure, opposite sides are equal, opposite sides are parallel. Still need some more.
One of the parallel sides is longer than the other.
No. Oh, okay, I understand what you're saying. One set of sides will be longer than the other set of sides for a rectangle. I understand that, but I still need one more major thing.
Is it closed-sided figure?
It's closed. That means it's quadrilateral. Already got that. Come on now. What's the most important part? It has to do with the corners.
They're 90 degrees.
90 degrees. I've got to have corners that are 90 degrees, or we sometimes call them right angles. Y'all learned that in 5th grade?
Yeah.
So I'm going to draw one instead of writing words for it, like that. And I'm going to put symbols on it that will define it for us. I'm going to put a double slash and a double slash. That means those two sides equal each other. I'm going to put a single slash and a single slash, meaning those sides equal each other. I'm going to put on this side an arrow, and on this one arrow. That shows that they are parallel. And on the top and bottom, I'm going to put a double arrow, which shows those sides are parallel. Now there's one last thing I got to do, and it's the corners. What do I do on the corners?
You can put like that little baseball base right there.
I call it a box. Your teacher called it a baseball base. I like that. But I just put a little box in each corner that says 90 degrees. That is our definition of a rectangle. Now folks, I'm going to also put up here one of these, even though we're not talking about today, square. It's not up here because they may throw one in us. All squares are rectangles. Not all rectangles are squares. So I'm going to draw a square up here because it is a type of rectangle. But it only has 1 slash, 1 slash, 1 slash, 1 slash, right? Alrighty? And then I can put boxes in the corners or baseball bases, and then I can go single. I'm not going to put the arrows. Y'all know it's parallel, okay? Alrighty? I put that in there because they're really a rectangle. Squares are rectangles. Alright. Now, we are going to cover a rectangle with squares. So if I want to know the area of this rectangle right here, all I got to do is count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 30. Wait. You stopping me? Wait, what are you saying to me?
You don't have to do that. You multiply.
I thought I need to count the squares to have the area.
Shortcut. There's a shortcut.
Oh, there's a shortcut. Oh, there's an easier way. Oh, there's another way. Thank goodness mathematicians came up with a formula or shortcut or mathematical process that makes it go faster. Or I would have to take and count all the squares inside of it. Or if I was given one that didn't have squares on it, I'd have to start drawing squares on it and then count them all. Think how long that would take. A long time. Thank goodness mathematicians discovered a formula that would help us speed up the process finding how many squares. Well, if I was doing this little one right here, this skinny one, how do I find out how many squares are in there quickly using mathematics coding?
Length times width.
Well, now, before that, I want to know how many squares are in here. Count what?
Squares on one side.
Wait. Which side?
Any side.
Which side?
The side and the top.
The top and the side.
The side and the top.
Okay, so you say count along the top. All right, count along the top.
No, under the.
Okay, count under it. Okay.
No, count the boxes on the top row.
Count the boxes on the top row.
Of the box.
Okay,
Inside.
okay. And then
We
what?
already did.
Now count the ones on the side going down.
And now count the ones on the side going down.
They multiplied them.
And then
Length times width.
multiply. What do we usually call this one going this way?
Width.
Length. What do we usually call the uppy downies? Width. So, mathematicians discovered that we could find the area by knowing what the length is, multiply it times what we know the width is, and that would count the squares for us really fast. Would it not?
Mhm.
Would. The problem is, sometimes we don't call the bottom the length. What do we call it sometimes?
Width.
Nope.
Height.
Nope.
Depth.
Nope.
Volume.
Look on your chart.
Side.
Look on your chart.
BH.
BH. Bottom.
Nope, not bottom.
Side.
Not side.
Something that starts with a B.
Right?
Bottom.
Nope.
Height. Base.
Base. Sometimes we call the bottom the base. What's H?
Height.
Height. Sometimes mathematicians call it base and height. Is it the same thing?
Yes.
Yes. Just called something different. We've learned that in math, haven't we? You just call it something different. So we're going to do base times height, or length times width. Makes it easy. Now, let's go to a parallel. We're going to do some examples in a little bit, but let's go to a parallelogram. What is a parallelogram? Parallelogram. Describe one for me.
Well, it's a shape that doesn't have 90-degree angles.
Doesn't have 90-degree angles.
Well, it does. Some can, but
Some can, but
Opposite sides are parallel.
opposite sides are parallel.
Sides are equal sides.
Opposite sides are equal.
It's got 4 sides.
4 sides, quadrilateral.
Oh.
Rectangle.
Turn to the side.
Shifted.
Do you see anything up here that says diamond?
Parallelogram.
You see anything that says rhombus?
Rectangle.
Rectangle?
Parallel.
Parallelogram.
Rectangle.
A squashed rectangle. So we can draw it like this. We can put double slash, single slash, parallel things. But let's don't put right angle things in there.
A circle.
Okay? That's our parallelogram. We see them right here. Here's a couple of them. Now I'm going to put this up here, pretty star right here, kind of important, because right now I'm going to say, I'm going to draw this because I'm tired of writing that big long word, parallelogram. So parallelogram, I'm going to say, does not have L and W. A parallelogram does not have L and W. It has B and H.
13 minutes.
Because it's
13.
bent. So, I'm going to tell you, when you have a parallelogram, you still have the bottom can be the base. Okay? But what changes is, over here, this was our L, and this was our W, wasn't it? Because it gets squished, it goes leaning. This side over here no longer is W or H. H is a straight up and down dotted line that connects the bases. When I want to see how tall you are, what number are we on?
We're going on 14.
Okay. When I say I want to measure your height, do you lean sideways? No, you stand up good and straight, up and down, and then we measure. The height of a parallelogram is the same thing. Now sometimes they draw that straight up and downy on the outside. It's still the H, the straight up and down line. Okay? Am I with me? Okay, 1430.